So now we're going to look at horizontal transformations, and that's on the yellow foldable that you have. And what I want you to notice about the horizontal transformations, we're still talking about how everything changes from the parent function, which is y equals x. Okay? Notice that when we change b and when we change c, they are both inside of the parentheses. Okay, if you remember A and D were not inside the parentheses, they were outside, but B and C happen inside parentheses. They're happening to the x, not to the entire function. Okay, so let's say we have B. If we're changing B, if B is greater than 1, then we have a horizontal compression. If b is between 0 and 1, which would make it a fraction or a decimal, then we have a horizontal stretch. If b is less than 0, which would make it a negative number, then we have a horizontal reflection. And you're probably thinking to yourself, Mr. Cohens, those are all backwards from the vertical transformations. You're exactly right. Okay? So you got to remember, if it's inside the parentheses, we think opposite. When b is greater than 1, it's a compression. When b is a fraction, it's a stretch. And when b is less than 0, we still have a reflection. Okay? Negatives are always going to be reflections. So let's look at what's going to happen with some examples. Okay? So we have b is greater than 1. So I could say something to like f of 3x instead of just f of x. And so what's going to happen is that means it is a horizontal compression, which in this case means it gets closer to the y-axis. So the line is going to look something like this. And the description is a horizontal compression by a factor of 3. Okay. Now down here we have where b is less than 1 but greater than 0, so it's a fraction. So we know that's going to be a horizontal stretch. So that means it's going to get closer to the x-axis. So it's going to look something like this. So this is a horizontal stretch by a factor of 1/2. Okay? Now when b is less than 0, again, a negative number, we just called it -1, then we have a reflection across the y-axis. So instead of this part being here, we're going to reflect it across the y-axis, which means it's going to go here. Same thing, this bottom part, reflect across the y-axis, goes here. Looks just like we reflected across the x-axis, but when we add more numbers to it, it's going to be reflected across the y-axis. So we call this a horizontal reflection. And that is across the y-axis. And so down here we put it all together, so we have -2/3 as b, so we've got f of -2/3 x is what that would look like. So we know we're going to have a reflection, and 2/3 is less than 1, so it's going to be a stretch, which means it gets closer to the x-axis. So it's going to look something like this. I reflected and I got closer to the x-axis. So we call this a horizontal reflection and a horizontal stretch by a factor of 2/3. Now remember, the factors of stretching and compressions don't include the negative. It's just the value of the number. The negative has to do with the reflection. Okay, so let's close that up and let's look at the bottom part where we subtract c from x. Okay, so if c is greater than 0, which means c is a positive number, then I am going to translate to the right. Okay? Remember, there's a minus sign there, and so when I'm subtracting a positive number, I translate to the right. If I'm subtracting a negative number, then I translate left. Okay, so it would be something like x minus -2, then that means I'm going to translate to the left. Okay, so let's see what that would look like. So I have c is greater than 0, so I've got f of x minus 2, which means I'm going to move the entire line to the right. Okay, so notice that I went from here over there. Move to the right, 2 spaces, so we call this a horizontal translation right, 2 spaces. Okay? So if we go down here, c is less than 0, we got a negative number, so it ends up being x minus -4, which is the same as x plus 4. I'm going to put x minus -4. Okay, so we can just see that. That means I'm going to move to the left 4 spaces. So I'm going to go back here to the left, and we're going to stay parallel. And move to the left. And so we call this a horizontal translation left 4. Okay. So now we're going to try it on our own. We've got a B and a C. B is positive and C is positive. So this is going to be the f of 2x minus 3. Okay? Because remember, it's x minus c, and since c is 3, it would be x minus 3, and then 2 times the x, because that's what b is. So we know that b is 2, so that means it's going to be a compression. Let's go ahead and write this first. A horizontal compression by a factor of 2, and it's a translation right 3 spaces. Okay? So I know it's a compression, which means the line is going to get closer to the y-axis, plus I'm moving it to the right 3, so it's going to be something like this. I compressed it to get it closer to the y-axis, and then I moved the entire line across 3 spaces to make the translation to the right. Okay? And so now let's try this one, where b is 1/4 and c is minus 3. So I've got f of 1/4 b plus 3, because it's the same as minus -3, which is plus 3. So I know that I have, because I've got 1/4, I've got a stretch, a vertical stretch by a factor of 1/4, and a translation left 3. So let's write that. Of horizontal stretch by a factor of 1/4, and it's a translation left 3 spaces. Okay? So we know because it is a horizontal stretch, the line is going to get closer to the x-axis, and we're going to move left 3 spaces. Okay? So we're going to have something that looks a little bit like that. I moved the line left 3 spaces, and I stretched it so it looks like it's getting closer to the x-axis. Okay? A lot of information to take in, I understand. So let's flip to the back real quick, and let's just see if we can do a couple of these. If I have f of x plus 1, okay, that means that this is a translation to the left 1 space, because it's c minus -1, and -1 would be moving to the left. So you have these other 4 that I would like for you to try on your own, and then we'll talk about them in Math Workshop.